All right, you guys, let's go ahead and get started here on lesson 5.11. This is part 1. This is 2-part lesson just because lesson we are doing tomorrow is going to be more or less the same idea. So in this case, we're factoring quadratics equations here. So we start off with equations that are going to be in standard form, and we want to go ahead and express them in factored form and solve for the zeros of the function here. So starting off, I do want to go ahead and start off with example 1 here, guys. And example 1 in this case says solve for the equation of x plus 5 times x minus 7 equal to 0. Now, in this case, guys, we've actually previously seen how to solve for the x-intercepts. In this case, we actually saw it earlier in the chapter. So if you want to go ahead and solve for x in this case, you want to go ahead and make each of the expressions that have a variable equal to 0. So, for example, x plus 5 here has a variable, so I'm going to go ahead and make that equal to 0. And also x minus 7 has a variable, so I'll go ahead and make that one equal to 0. So we're going to go ahead and break this apart, and we have x plus 5 equal to 0, and x minus 7 equal to 0. So in this case, once again, starting off with the left-hand side here, I want to go ahead and solve for x. So in order for us to solve for x, I need to get rid of this positive 5. So in order for us to get rid of it, I will be doing the opposite, which is subtracting 5 to both sides. This cancels what's on the left-hand side, and we have x equals negative 5. So this is for our left-hand side. Now let's go ahead and repeat the same process on the right-hand side. So on this one, once again, we want to go ahead and leave the x alone. So I'm going to go ahead and add 7 to both sides. And that's going to cancel this. And we have x equals 7. And this here, guys, would be our answer. So this is actually what we're going to be doing in today's lesson. This is actually the second part of what we're going to be doing. So let's go ahead and do a bit of a review here for the first part. Now, in this case, guys, the first part, once again, does talk about a quadratic equation. This quadratic equation is actually in standard form. If you guys don't recall what standard form is, standard form in this case talks about having your terms written from the highest exponent to the lowest. And in this case, we have our quadratic equation of ax squared plus a bx plus a c. Now, I do want to go ahead and do some labeling here because we do need these values. So starting off with the a in this case, guys, a in this case represents our leading coefficient. A represents the leading coefficient. B in this case represents the x coefficient. And y in this, or c in this case, represents the constant. So once again, a is our leading coefficient. It's a number in front of the x squared. B in this case is our x coefficient. It's a number in front of the x. And c in this case, guys, is the constant. It's the number that's by itself. It has no variable. It's just a number. So let's go ahead and take a look at this when we're factoring. In this case, guys, we're working with quadratic expressions, which means that the highest exponent is going to be a 2. So because the highest exponent is going to be a 2, we can actually use the diamond method here. Now, how the diamond method works in this case, guys, is we do want to go ahead and first identify a, b, and c. And we actually get that from our quadratic equation. So once we have that, we'll go ahead and get it from there. And in this case, how the diamond works is that on top you have a times c, and on the bottom you have b. So you need to find in this case 2 factors that multiply to your top, which is a times c, and at the same time we'll be adding to b. So let's go ahead and see this here, guys. Starting off with example 2, we want to go ahead and solve for x here, and we have x squared plus a 3x minus 28 equals 0. So first thing you want to go ahead and check, guys, is you want to go ahead and check for GCFs. This is just to make your life simpler in this case. And GCF in this case talks about any number that can divide into the 1, because there's an invisible one there, a 3 and 28. And thankfully for us, guys, there's actually no GCFs other than 1 because there's no bigger number than 1 that can go into all 3 of them. So we're not going to be factoring out anything there. Now, since we don't have a GCF, we do want to go ahead and move on to identifying our A, B, and C values. So we want to go ahead and identify A, B, and C. Now, a in this case, once again, represents the number in front of the x squared, so that's going to be a 1. B in this case represents the number in front of the x, which is the 3. And C in this case represents the constant, the number that's by itself, negative 28. So let's go ahead and build our diamond on this side. And in this case, guys, I have A times C, and on the bottom, I have a B. A times C is going to give us negative 28, and B in this case is going to be 3. So in this case, guys, we're looking for two numbers that multiply to a negative 28, and at the same time, we'll be adding to a 3. So two numbers that multiply to our top number, and at the same time, we'll be adding to a 3. In this case, those numbers for us would be a 7 and a negative 4. Once again, if I bring out my calculator here, and if I do 7 times a negative 4, I do get negative 28. And if I do 7 plus a negative 4, we still get a 3. So that works for us. Now, once you have your factors here, you want to go ahead and check what your value for A is. Now, if A in this case is equal to a 1, then you're pretty much done with factoring here, and you could actually write your binomials. So I'm going to go ahead and do that here. And my binomials in this case is going to be x plus a 7 and x minus a 4. Now, once again, these numbers here, the 7 and the negative 4, are the ones that we just got on this side here. So this one is the same one as the ones that are in here. So in this case, guys, we're almost done here. We want to go ahead and once again solve for x here. So just like we did in example 1, if we want to go ahead and solve for x, we have to make basically each expression that has a variable equal to 0. So x plus 7 is one expression and x minus 4 is another one. So let's go ahead and break those up. And I have x plus 7 equals 0 and x minus 4 equals 0. Now let's go ahead and solve for x in this case, guys. On the left-hand side, I'm going to go ahead and subtract 7 to both sides. And that's going to give us x equals negative 7. Now, moving on to the next one, we're going to go ahead and repeat the same process. So I'm going to go ahead and add 4 to both sides and add 4. And in this case, x is going to equal a positive 4. So this here, guys, would be our solutions. That is example 2. Now, let's go ahead and take a look at example 3. Once again, same idea, guys, same idea here. So first off, if we check for any GCFs, any numbers that could divide into 1, 18, and 81, there actually isn't any other than 1. So then let's go ahead and move on to identifying A, B, and C. So A, B, and C. Once again, since our equation here is in standard form, I know that A is going to be the number in front of the x squared, B is the number in front of the x, and C is the number in front, or the number that's by itself, actually, the constant. So those are A, B, and C. So let's go ahead and build our diamond now. And I have A times C on top, and I have B on the bottom. A times the C is going to be 81, and B in this case is going to be negative 18. So in this case, let's go ahead and think of two numbers that multiply to an 81, and at the same time, we'll be adding to a negative 18. Now, those two numbers for us would be 9 and 9. So 9 times 9 gives us 81. But if I add 9 and 9, it's not going to give me negative 18. So I'm actually going to make it negative 9 and negative 9. Because negative 9 times negative 9 is going to give us 81. Let's go ahead and check here. Negative 9 times negative 9 is 81. And negative 9 plus a negative 9 is going to be negative 18. Now, let's go ahead and check here, guys, for our values for A. And A in this case is going to be a 1. So because A is a 1, I could actually write my binomials on this side. So that's going to give us x minus 9 times x minus 9 equal to a 0. Now here, guys, we are going to be making each of them equal to 0 here. So we have x minus 9 equal to 0 and x minus 9 equal to 0. So on the left hand side, guys, I'm going to go ahead and add 9 to both sides. And in this case, both of these x minus 9, we actually have a repeated value here. we're actually going to be getting the same solution for both of them. So in this case, if I were to graph this on the graphing calculator here, what this is telling me is that I actually only have one value for x, which means there's only one x-intercept at x equals 9. And that's our answer, only x equals 9. All right. And in this case, guys, you do have a practice problem, and this is your practice problem to work on.